Hi everyone, welcome to the soil texture webinar. This session will be presented by Paul Hazlett. Paul is a forest soil scientist with Natural Resources Canada, the Canadian Forest Services in Sault Ste. Marie. His research focuses on primarily the impacts of atmospheric deposition in forest management, practices on nutrient cycling and forest soil sustainability. Today, this session will provide you with an overview of soil textures and its importance as a soil physical property. Paul will be giving instructions on a flowchart for determining soil texture by feel. Paul, whenever you're ready, you can take it up. You can take it away.
Thanks for the introduction, Diana, and thanks for everybody joining in. Just to let you know, I'm sitting in Sault Ste. Marie in a forest soil laboratory within a Natural Resources Canada Canadian Forest Service institution called the Great Lakes Forestry Centre. So I assume we've got people scattered from all across the province, but it's really quite novel and a fun way for me to connect with you across the province, all you students that are interested in Envirothon and environmental concerns and the environment in general. So as Diana said, I'm going to cover today soil texture, what it is, why it's important, and how to determine it. I've aimed this webinar at really somebody that hasn't been involved in Envirothon before and maybe doesn't have any idea about soil texture, so it's an initial primer. But I think it could be helpful as well to students that have been in Envirothon before and know a little bit about it, so some review for them. The other thing to let you know, even with the start there with a little bit of disruption, a couple of times I'm going to try and switch between showing you some slides with some information on them to some hands-on, looking at some samples and actually determining soil texture by feel later on in the webinar. So we'll see how all that goes. So just a quick outline of what I'm going to present today. A little bit about what is soil and what is soil structure before I get into texture. Introduce the textural triangle to you. Some of the ways that we determine soil texture. Then also the hands-on part of the demonstration looking at soil texture by feel. And then a little bit of an explanation about sort of why we care about soil texture and some reasons why we consider soil texture the master soil physical property. And then we'll have some time at the end for some questions, and hopefully you'll have some questions. So just to start off, mineral material is just one component of soil. So when we look at soil, it's made up of 4 different components. Mineral material being the largest amount in an average soil sample, about 45%. Organic materials about 5%. And then the other 50% of soil is what we call pore space. And it really consists of air and water, and these amounts of air and water differ depending on the conditions of the soil at any particular time that it's sampled. So that's the reason for that dotted line on the left-hand side of the pie graph there. So you can imagine if we've had a long droughty period with not much rain, that the soil will be dried out to some degree, and there'll be a greater percentage of that pore space would be made up of air and less amount of water. And the reverse of that, if we've got a lot of heavy rainfall, the soil's becoming saturated, and some of that larger amount of that pore space is filled with water rather than air at that point in time. But when we're talking about soil texture, the important thing about this diagram is we're really talking about that 45% of the soil that is mineral soil. So this is mineral material, soil material that's come from the weathering of rocks that has produced mineral soil material. And I'm going to talk a little bit more about how we define that and how we define texture. But like I say, the important thing to know is that's the component that we're looking at when we're looking at soil texture. And one thing that's complicating about that, and now I'm on the soil structure slide, is that the mineral soil particles that are in any particular soil sample can actually arrange themselves into secondary particles. So if you went out into a farmer's field, your own backyard garden, or a forest, it's possible that you could find these soil structure, that is the smaller mineral particles aggregated together into these secondary particles. And that makes it complicated in terms of understanding soil texture, because these aren't the primary particles, they're secondary particles. So we call these units of structure, soil structure, we call them aggregates or PEDs. And they're smaller soil particles that I'm going to talk about in more detail in a minute that are come together to form different structures. So you can see on the left side of this slide some of the different structures that we might get when we get these aggregation of the primary particles. And I'm going to just switch off and stop sharing now and show you a couple of hands-on examples where we've got some soil structure that's formed. And again, you're going to forgive me. Diana, you're still there? Maybe not?
I'm still here, Paul.
Okay, good. So I'm just switching over now, and I'm going to show you actual hands-on sample where we've got soil structure. So in this particular case, all the primary particles have come together and they're forming a blocky structure. And hopefully you can see that in the webcam with this particular sample, that we've got a secondary structure, a blocky structure. Another example of structure is granular. So here's a soil sample where the primary particles have aggregated together to form a granule type of structure. And then structureless soils would be like sandy soils where the particles don't aggregate at all. So in this particular case, I've got, it's almost like a sample of beach sand. I don't know how well this is showing on the webcam, but in essence, there's no structure at all. The particles aren't being held together at all. Okay? So that's the idea of soil structure. I'm going to flip back to the presentation now. Oh, it took me right back to the beginning, it looks like. Oh no, there we go. Okay. So soil texture is when we break down those aggregates of soil structure into their primary particles. Okay? So soil texture, the actual definition of it, refers to the size of the mineral particles that make up a soil sample. And there are three different sizes of soil particles. The primary particles, sand particles are the largest, clay particles are the smallest, and silt particles are intermediate. So again, just to refresh, we're talking about the mineral component of the soil sample, not the organic component or the air or the water, obviously, just the mineral component that's made up of sand, silt, and clay. And the figure on the right gives you an idea of the relative sizes of sand, silt, and clay. We further divide down the sand sizes into coarse sand, medium sand, and fine sand. And again, this diagram on the right gives you an idea of the relative sizes of different sand as compared to silt. So again, texture, strictly defined, is really just the percent of sand, silt, and clay that there are in any particular mineral soil sample. Okay, so we do have strict definitions about these different particles and their actual sizes. So the top part of this table talks about what we're calling the primary particles, again, the sand, the silt, and the clay, and the diameter of these particular size of particles. So clay, as an example, those clay-sized particles are less than 0.002 millimeters. And you see the other ranges there, ranging up to very coarse sand, which is a primary particle that's 1 to 2 millimeters in size. And then you can see the different range for silt and the other classifications of sand. So these are the primary particles. You'll often hear people refer to this as the fine earth, the less than 2 millimeter fraction of soil, so particles that are less than 2 millimeters in diameter. And oftentimes I'll refer to this is really the soil, okay? That fine earth fraction of any particular soil is the soil itself. I've also added to this table the idea that within any particular soil sample, you also find coarse fragments that are greater than 2 millimeters in diameter. And within soils, we also have a classification scheme for those coarse fragments, again, based on the diameters that you see below, in greater than 2 millimeter fraction: gravel, cobbles, stones, and boulders. But again, when we're focusing on texture, which is the topic of the conversation today, we're really just talking about those primary particles, the fine earth, less than 2 millimeter, the components of sand, silt, and clay within any particular sample. Okay, so moving on to the textural triangle now. It's very difficult to find a soil sample that's composed completely of 100% clay, 100% sand, or 100% silt. Most samples are a combination of sand, silt, and clay at different percentages. So the textural triangle that I presented here, and again, I don't know, this may be the first time seeing it for some of you. For others of you, maybe not. You've done some Envirothon before. You've done this in a geography class or something in school. Is a way to look at the different percentages of sand, silt, and clay in a sample, and then assign what we call a textural class to that various percentage of sand, silt, and clay. And I'll show you some examples in a minute on how we use this triangle, but just to walk through it here. So on the left-hand axis that says percent clay, the horizontal lines running across this textural triangle go from 0 at the bottom to 100% clay at the top. On the on the right-hand side, we've got the percent silt. So the percent silt are the lines that are running from the upper right to the lower left. And you can see from the top of the triangle to the bottom right-hand corner, those go from 0% to 100% silt. And then across the bottom axis, the percent sand, we go from 0% sand to 100% sand across that axis. And again, the lines you follow are those that are running diagonally across the triangle from the lower right to the upper left. Okay? So this textural triangle gives us, as I said, the textural class for any different combination of amounts of sand, silt, and clay within a sample. And just some other terminology that we use when we talk about a coarse textured soil, we're really talking about a sample that's composed of medium to coarse sand particles. So that would be down in the lower left-hand part of the textural triangle where we have sands and loamy sands and sandy loams. Those would be considered coarse textured soils. And of course, the coarse comes in because of the fact that the sand-sized particles are the larger particles of the sand, silt, and clay. In the same way, we talk about fine textured soils. And again, in this case, we're talking about a fine soil texture being one that has smaller particles in it. And of course, the smaller particles are the clay-sized particles. So a fine textured soil would be one that's up towards the top of the triangle, a sandy clay or a silty clay that has a high percentage of clay in that particular soil sample. So we call that fine textured. So you'll often hear people refer to coarse textured or fine textured soil, and that's actually what they're talking about when they're describing those different soil types. One other thing to point out, and I'm going to highlight this a little later in the presentation, is just what we have here in the middle of the triangle is what we call a loam soil texture. That's the loam textural class. And some of you may have heard of loam. Often I ask students and they say, oh yeah, my parents said to me, my grandfather said to me that he's getting a load of loam for the garden, or a load of loam to put out grass on the front lawn. Well, loam, in the case of the textural triangle, is kind of the sweet spot in terms of the amount of sand, silt, and clay. So it's got some clay in it, some sand in it, and some silt in it. It's not at the extremes at each corner of the triangle, it's in the middle. So if you're getting a load of loam for your front lawn or for your garden, you could be getting a soil load that has a mixture of sand, silt, and clay in it to use for that purpose. So how do we use the textural triangle then? I'm just going to give you two examples here, and we'll look at them together. We can use it in two different ways. The first way is we can determine the textural class of a particular soil. So if through some method we determine the amount of sand, silt, and clay in a particular sample, then we can go to that triangle to come up with the textural class. Conversely, I could give you the name of a specific textural class, and then you could give me an example of the percentage of sand, silt, and clay that would make up that textural class. So just looking straight at the textural triangle and looking at the examples that I've given on the page before. So on the right-hand side, I said, let's take a sample of soil that has 30% clay, 60% silt, and 10% sand, and find out what the textural class is for that particular sample. I never asked you before, Diana, can you see my mouse on the screen?
Yes, I can.
Okay, so we'll just use it to trace a class. So here we're over at 30% clay on the clay axis. We're tracing that across on this axis. We've got 60% here on the right-hand axis. We're tracing that down. And then we've got 10% silt, 10% sand on the bottom axis. We trace that up. Where those three intersect, that's the particular textural class that we assign to that combination of sand, silt, and clay. So where the star is there, how we identify this particular sample, it's a silt clay loam. Okay. Now the other example I talked about was if I said to you, can you give me an example of the amount of clay, silt, sand in any particular textural class? And again, the example I selected was the sandy clay. So here's the boundary marked by the mouse here of the sandy clay textural class. And one example of a soil with the correct amount of sand, silt, and clay to be classified as a sandy clay would be 40% clay. So again, I'm on the clay axis here, following across horizontally to this point. 10% silt on the silt axis, drawing down along this diagonal to this point there. And 50% sand, now on the sand axis at the bottom, tracing up. Those 3 points intersect right there. So again, as an example, I could say to you then, okay, an example of a sandy clay soil would be a soil that has 40% clay, 10% silt, and 50% sand. Now again, that's just one example. I could choose any point within this triangle that's identified, and also that would be classified as a sandy clay. So the idea of these textural classes is to group together different percentages of sand, silt, and clay and describe them because they might have similar responses to the amount of nutrients in the soil, the drainage of the soil, and several other soil properties and behavior of soils. I'm going to talk about those in a few minutes as well, but that's the overall idea of the soil textural triangle. So that's one textural triangle. I also wanted to tell you before we moved on to the next section that over time you may have already or you may see another textural triangle that's used. And this often with different students that I work with when they're exposed to this, there's some confusion. On the previous triangle, we had 3 different axes with the amount of sand, silt, and clay. This particular triangle is an abbreviated triangle that only has 2 axes. So it shows the percent clay on the left-hand side here on the y-axis from 0 to 100%. So again, as you move up from the bottom of this triangle to the top corner here, you're increasing in the percentage of clay in any particular sample. And then on the bottom axis, you have the percent sand. So again, going from 0 on the left-hand side to 100 on the right-hand side. And as you move across here, textural classes that have increasing percentages of sand. So in this particular triangle, everything's exactly the same in terms of the textural classes and the amounts of sand, silt, and clay, but it leaves out the percent silt access. So how do you calculate percent silt here? It's really just the difference between 100% and the amounts of sand and clay in any particular sample. So just to say you may be exposed to both of the triangles, and in Envirothon and anything else, you should be able to use both triangles. But just remember, you could see both of them, and this one doesn't include the silt axis. It just includes the sand and clay axis. But you can use it functionally in the same way. You could calculate an amount or determine an amount of sand, silt, and clay in a sample and identify the textural class, or you can take any particular textural class and then pick out how much sand, silt, and clay is in that particular sample. Okay? So those are a couple of textural triangles. So how do we actually determine soil texture? There's several methods to do it. Some are more simple than others. Some are more expensive than others in terms of outfitting a laboratory to do the textural determination. So one that's been used for quite a long time and is still used a lot for larger soil particles, the sands, and even some of those coarse fragments that I talked about that aren't texture, but at least looking at the size of particles in any particular soil sample, is just using sieves. So here on the left-hand side of the slide, we've got a nest of sieves, and these sieves would have sieve sizes or openings that decrease as you go down in the nest of sieves. So you pour a soil sample in the top here, you shake the sieve. There's a machine you can put this on to shake it. The soil comes through the sieves, and the different sized particles, the small ones move all the way to the bottom of the pan. The larger ones, the sands, are held in the top part of the sieves. And then after you've done this, you can take the amount that's saved in each sieve and weigh those amounts of sand, silt, and clay, and then determine what percentage they were of the initial weight of the soil sample. Okay, so that's a simple technique of sieving. The precision is not so good with this technique, and also it's really important in this technique to break down the soil sample to its primary particles. So you have to either use some kind of a mechanical mill or a mortar or pestle or a rolling pin to break up those structural aggregates that I talked about earlier. You can imagine if you didn't break down those aggregates, you might be collecting a part of the soil sample in a sieve like this, and it might be showing up as a sand particle, but it's only because you didn't break it down enough into its smaller sized particles. Okay, so that's the first one, sieving. The second one, which is very commonly used, is and it's more precise than the sieving method, is something called the hydrometer method. And the parts that are needed, or the equipment that's needed for the hydrometer method, is shown here. First of all, we've got a milkshake machine. And what we do is we take the soil sample and put it in a cup like this with distilled water and put it on the milkshake machine and run that machine for several minutes. And the idea of that is we're actually breaking down those soil aggregates to the primary particles. Okay? So we use the milkshake machine to mechanically do that. Once we're done that process, then in the suspension, we just have sand, silt, and clay broken down by aggregates. And then what we do, this is a hydrometer. I don't know if any of you have ever seen or used one before. It's commonly used in the maple syrup industry. It's used for measuring the density of liquids or suspensions. And in this case, what we do is we'll mix up this sample of soil that has sand, silt, and clay in it, and then we'll let those particles settle. And we'll measure the density of this suspension at different time points to give us an amount of sand, silt, and clay in that sample. So you can imagine when we mix up this suspension of sand, silt, and clay, once we're done mixing it, the first particles that settle, and you can actually see them in this slide, are the sand particles. they're the bigger ones, they're the heavier ones, so they settle quickly. Silt settle next, and then clay will stay suspended for quite a period of time in the suspension. And the change of the density, basically how high this hydrometer floats in the suspension, will give us a calculation to determine the sand, silt, and clay on that particular sample. So that's the hydrometer method. The third one that I put up here is something called laser diffraction. So this is a more expensive technology, more recent technology than the other two methods, where again, you have to break down the aggregates of your soil sample. You put them in this analyzer and fire a laser at them, a light, and the particles diffract the light in different ways depending on the size that they are, whether they are sand, silt, and clay. So a very precise method to do this, a very fast method to do a lot of samples, but a more expensive method that you obviously wouldn't have except in some scientific laboratories to do that kind of work and to be doing lots of samples. So all three of these, like I say, will give you a percentage of sand, silt, and clay in any particular soil sample that you have. Okay. The last method, and the one we're going to focus on today, is a method that anybody can do. You as students of Envirothon, anybody that's got a backyard garden and a farmer, anybody can do this to determine soil texture by feel. And we're going to go through this key in a minute, and I've got some actual samples here I'm going to try and show you going through the key. But the soil texture by feel technique is a field method that you can use to determine texture. And again, because of that, it's not going to be nearly as precise as those other methods that I talked about. But with some practice, it can give a good estimation of the texture of any particular soil sample. We can identify not the percentage of sand, silt, and clay specifically, but the textural class that any particular sample belongs to. The other thing I want to say before we go through this key here and when I do it hands-on is the fact that there are several different soil texture by feel methods. So I'm just presenting one of them here today, and there are quite a few of them, and they're made up of a combination of different tests to determine texture. And the three that this key uses are the ball squeeze test, the ribbon test, and the feel test. And that's what I'm going to go through. One of my most fun things with students is to talk about, there's one textural test that's actually the taste test. And we use that test to determine the amount of sand in a sample, because sand is very gritty to taste. If you've ever been on the beach and rolled over off your towel and put your face in the sand by mistake, you know what I'm talking about. But that particular test isn't included in this particular soil texture test by feel. Okay, so again, just to say, there's more than one of these out of here, and I'm just exposing you to one of them today that's made up of three different tests. So the first test, and we're going to go through this, like I say, with a sample in a minute, but the way this key works is we take a soil sample and we wet it with water. If you're doing this in the lab on a dry sample, you can use a water bottle to do that. If you're in the field and you've got a moist sample from the field already, you may not have to have a lot of moisture to it. You can do that. So the ball squeeze test is you're actually trying to form your soil into a ball and see how strong that ball is. So you can well imagine that coarse textured samples with a lot of sand in them, will not make a good ball. But as you increase the amount of clay in the sample, you'll end up with a ball that resists breaking a lot. It's a lot harder to break the ball, resists the breaking, so it has a higher clay content. If your sample does not make a ball when it's, or does not make a ball when you squeeze it, or falls apart easily, then you've figured out right away that you've got a sand. The next step is to take that ball and form a ribbon with it. And again, the ribbon test helps to estimate the amount of clay in a sample. If you can't make a ribbon, but you can make a ball, then you can see on the left-hand side of this key, we identify that as a loamy sand. And then as you move down, we will make different lengths of ribbons, less than 2.5 centimeters, between 2.5 and 5, and greater than 5 centimeter ribbons before breaking. And then you move down into these different parts of the key from the left to the right. So you've got loams, clay loams, and clays, depending on the length of your ribbon in your ribbon test. And then the final test is what we call the field test. And put simply, sand feels gritty, we all know that. Clay feels sticky, and silt feels smooth. Somewhat like flour, really, is what silt feels like. So if you're into baking a lot, you know what flour feels like, that's what silt will feel like. So once we form the ribbon, then you decide, does the sample feel very gritty? Does the sample feel very smooth? Or if it doesn't feel either of those, very gritty or very smooth, then you end up down here in the bottom. So either a sandy or silt or just a loam in this case, depending on where we go in the key here. So I know I might have put you in the maze a little bit there, but my intention now is to actually do a couple of samples to show you what they look like when we start doing this test. Okay, so I'm going to stop the share now and go to the camera. Do you see the camera, Diana?
Yep, all looks good, Paul.
And you can hear me?
Yes.
Okay, so here's what we need to do the texture by feel. So we need a water bottle. We need a ruler to measure the length of the ribbons that we're going to create. And then, of course, we need our soil samples. So I brought a couple in here today. I'm going back to this sand sample. So it says in the key, take 25 grams of soil. That would be something around the size of a tablespoon of soil, or maybe a little bit more. I think you can still see that okay. So the first step in the key, I'm going to put a little more in. The first step in the key is to take some water in the water bottle and wet up that sample. And what you're doing with this sample now is you're trying to make it into a ball. Okay? So here I'm forming the sample into a ball. And I can tell right from the outset with this sample, and I've chosen this sample because of the fact that it is got a lot of sand in it. And I can feel that right at the outset, and you may even be able to see that on the camera. If you have water running through your hands, you've added too much moisture, then with any of the samples you do, you can add some more soil to it. On the other hand, if you're unable to get it wetted up like a mud pie, you have to add more water to the sample. So that's another thing to know, and you see that in the key there. Now, the way the key works, it says apply slight pressure to the ball and see if it breaks down. And I guess what I would argue at the outset here is that no matter what kind of texture you have, if you apply enough pressure, you can break down the ball. So another thing I might do is actually move this ball from hand to hand to see if it still keeps form. And in this case, this particular sample, while it's keeping some shape, it's starting to break apart. It's easy to break up the sample. So in this case, we don't get far in that textural key. We're actually having a sand textural class here. So we're right at the first break point in the key where we've just got a sandy soil. So the end of it, this soil is sand textured, okay? We can't make a ball with it of any substantial nature, okay? I'm gonna switch to another sample. Give me a second here. And we're gonna go to the other extreme now. So I've got another sample. And I can tell right away this is a finer textured sample. It's dried out a little bit, but in this particular case, I've added the moisture to it, and now I'm forming it into the ball again, okay? And you can see immediately the difference that this sample has a higher percentage of clay in it. So the sample is forming a ball. it's very resistive to breaking down, completely the opposite of that other sample. So we move through that part of the key to the point where now we're going to make a ribbon of this soil, okay? And I often say to students, a ribbon isn't a worm, okay? Some of the keys say just take the sample and push it up with your thumb over your forefinger and make the ribbon. But I often say again to students, if you press hard enough, you can just about break any kind of ribbon, even if it has a lot of clay in it. So what I recommend is you use your other hand and you make that ribbon a uniform thickness, a uniform width, and then you hold it, hopefully you can see that, over your forefinger. And what you're trying to see is how long this ribbon extends over your forefinger before breaking, okay? So your pointer finger. So again, hopefully you can see here on the webcam that in this particular case, the sample is going well over my forefinger. If I measure it, it's actually greater than 5 centimeters. So we move right to the right side of the key, and we'll go through that. I know you can't see the key and the sample at the same time, but you're into the clay class because you have so much clay in the sample, okay? So that's the ribbon test. That's a really good ribbon. Now the third part of the soil textural key that we're talking about, then you take a small part of that sample and you put it in the palm of your hand and you add an excessive amount of water to it and then rub it in the palm of your hand, okay? And what you're feeling for here when you break that sample down is you're feeling either for grit, which would indicate a sand, or you're feeling for that smooth silt, okay? So in this particular case, the sample is very smooth. There's as well as some clay, there's a lot of silt in this sample. So the final textural class for this particular sample would be a silty clay, okay? It was able to form a ball. It has a long ribbon greater than 5 centimeters, and using the field test, it feels extremely silty, okay? Nice and smooth. So that's the textural class for that particular sample. So what I've showed you are sort of two of the extremes, a sample with a lot of clay and a sample that's a sand that you can't make any kind of ribbon with, you can't even make a ball. Third sample I have here today is a more intermediate sample. And to be honest, what I find with students determining a sand and a clay, those extreme ends where you have high amounts of sand and clay or sand or clay in a sample is fairly useful. It's more difficult to determine the textural class for those intermediate classes, okay? So here again, I'm gonna do this sample, taking the water bottle, I'm gonna wet it up and make a ball, or try and make a ball. And the intermediate classes where you've got a mixture of sand, silt, and clay in any particular sample are harder to determine, certainly for beginners, for sure. Okay, so now I form my ball. I hope you can see it. It has some sand in it, but not enough that the ball breaks down when I toss it back and forth or squeeze it. So we're moving out of a sand, we're moving past a loamy sand, and now we're gonna make a ribbon with this particular sample. So again, trying to form it and measure the distance that the ribbon forms before it collapses on the edge of my finger. I don't know if you saw that or not. So obviously this particular sample doesn't have near as good a ribbon as that clay sample that I demonstrated with earlier. And if I measure this where it's collapsing off the end of my forefinger by its own weight, it would be in the short ribbon class less than 2.5 centimeters, okay? So in the key, we're on the part of the key where we're looking at loam textural classes. So then the next step again is to take a sample of that, put it in the palm of my hand, wet it up a lot, and feel it with my index finger from my other hand. And again, I'm feeling, is it very gritty or is it very smooth? If it's neither of those, it's somewhere in between. So in this case, I am feeling a lot of grit when I do this. So the final textural class for this particular sample then would be a sandy loam. Okay, so it was able to make a ball. It had a poor ribbon, less than 2.5 centimeters. But when we did the feel test, we were able to feel a lot of grit in the sample. Okay, so those are the three samples that I wanted to show you today. So we had all, I'm just going to rinse my hands here before I go back to the computer. So we had a sample that was not able to even form a ball, that was a sand textural class, a sample that was able to make a ball and a very good ribbon and felt very smooth, a silty clay, and then an intermediate texture that ended up being a sandy loam. Okay, I'm going back to sharing the screen now for 2 final slides, and then we'll be done and have some time for questions. Okay. And so here's the 3 parts again, just to review the 3 parts of the key that I went through: the ball squeeze test, excuse me, the ribbon test, and making a poor, a medium, or a good ribbon, and then the feel test. And again, one of the key things I'll point out before we move on from this is that when you look at this key, it says, does the soil feel very gritty or does the soil feel very smooth? So it's somewhat subjective, and that's part of the reality with these kinds of feel tests, is that it takes a lot of practice for you and me together to determine if we both think a sample is very gritty. So when we're doing this with students that work for us in the summer and we're doing a lot of samples, we meet together with some standard samples to make sure we're all on the same page to determine what's feeling very gritty or very smooth. And again, if it's not very gritty or very smooth, then we default down to the last classification of the textural class here in the lower part, either a loam, a clay loam, or a clay. The other part of determining soil texture is also determining the sand size. So I showed you earlier the difference between very fine, fine, medium, and coarse sand. So if you do your textural identification and come out with a sand or a loamy sand or any texture that has sand in the name, you can also optically look at that sample and determine what kind of sand it is. So again, it's a very, it's somewhat of a practice technique to learn what very fine sand versus fine sand looks like. So in addition to having a sample that would be a loamy sand, you could have a sample that's a coarse loamy sand, or a loamy coarse sand, sorry. Okay, just finishing off here. So why do we care about texture? Why is it important? And why did I say right at the start of this webinar that we call it the master soil physical property? And this table just gives a brief summary of some of the properties or behavior of soil that are influenced by texture, okay? So really what this is saying to us is that it's useful to determine texture because it has a bearing on all of these really important soil properties. So whether you're working in your own backyard garden, whether you're a farmer, whether you're looking to build a building and want to know what the holding capacity of a particular soil is, it's worthwhile to know the texture. And just with the feel method, you can determine it quite quickly. So just looking at a few of them, the water holding capacity of the soil. So as you can probably imagine, you don't see many things growing on the beach. And one of those reasons is because sand on a beach doesn't have a very high water holding capacity. And that's coupled with the drainage rate. Water moves quickly through a sand. It's held more tightly in finer texture or clay soils. When we're talking things, aeration of the soil. Sands have a better aeration because they have larger pore space, larger pores in the soil. They warm up more rapidly in the spring in comparison to clays. Nutrients are stored more easily within, or to a larger extent within clay soils rather than sandy soils. So sandy soils are generally quite nutrient poor. Then if we look at some things around the leaching of pollutants, or if we wanted to seal a pond or a landfill, clay soils would have a better capacity to seal a pond or a landfall than a sandy soil. Okay, so those are some examples of why texture is so important. And just the last couple of points on this slide. Also in forests, soil texture can influence what different trees and plants grow in a particular place. Certain plants have adapted to live in different textured soils. And also, based on all those things that I showed above, when you're talking about what the best management practices are in agriculture or in forestry, those best management practices can be adopted for different soil textures. So an example of that in forestry, you wouldn't want to move into a site that has a high amount of clay in the soil during the wet period because it'll be have a high water holding capacity, poor drainage, and that'll cause rutting when you do your operations on those kinds of soils. So again, just to say, texture is really important. It's really easy, it's really important to many different properties within soil. So a question I often get, and I'm coming back to the whole loam idea again, is what's the ideal soil for plant growth? And it's really this idea of the loam, a mixture of the amount of sand, silt, and clay. And the loam can provide a balance between the water holding capacity of the clays and the nutrient availabilities of the clays and the drainage abilities of the sands. So star in the middle for the loam there. I think we're not bad on the time here. We've got time for a few questions. So I just wanted to put up a few other resources there. If you're looking for information about soils, if you're starting to work as teams or prepare for competitions or meeting as clubs, whatever, there's the Forest Ontario website, but there's a couple other ones that I'm part of. The Soil for Youth website has some information about soil. And the Soil Science Society of America also has a lot of information about soils as well. Okay, that's all I got here. I think you're there, Diana.
Hi, Paul. Thank you very much for that very informative webinar on soil texture. We'll kick off the Q&A with a question that I have. So when you mentioned the different methods of determining soil texture, I'd like to know if you by chance know what the most preferred or accurate method of determining soil texture is?
The most accurate method?
Yes.
Yeah, would be the laser diffraction method.
Okay, and why is that?
Again, it's a technology that's been built to use the most up-to-date technology that there is out there using light to look at the size of particles in any particular soil sample. So it's the most accurate, but again, it's the most expensive technique as well. And really, in some respects, the idea of the textural classes is, in some cases, we don't need to know exactly what the amount of sand, silt, and clay is. We just need to know approximately what it is so we can determine what textural class it fits into and how the soil will behave in terms of those properties and the behavior of it that I talked about in the end of the lecture there.
Okay, thanks, Paul.
Yeah.
I have one more question for you.
Yeah.
This might be a very vague question, but I'm just wondering. You mentioned that loam is the preferred soil for plant growth. Is that the same thing for trees and other plants?
Yeah, for sure. That's the same. A loam texture, again, balances off the ability to have fairly good drainage, but also has the properties of the smaller sized particles in terms of their high nutrient holding capacity and some water holding capacity. The one thing I didn't mention there that I always find really interesting, and I've done it myself, a lot of times when we're talking about landscaping and so on, a lot of people think of a loam as a soil that has a high amount of organic matter in it. So it's funny, a couple of times I've had people say to me, I asked this contractor to bring me a loam, and he brought me this brown type of soil and dumped it in my front yard. And I said, well, he could be strictly going on the idea that the loam is a textural class. But loam has been, I mean, it's used equally as much as a term describing a soil with a high amount of organic matter in it that, again, could be a good soil for a garden or to put a new lawn in as well. So loam has, I guess, a couple of meanings. In the strict case that we're talking about here today, it's a textural class.
Okay, thank you, Paul. Well, it seems as though we don't have any more questions as of right now. So I'm assuming that we can finish off this session. Before you guys head out, I just want to thank you guys for hanging in and watching this session. And I'd also like to remind you that we have upcoming webinars in the future. I want to go and thank you, Paul, for teaching us about soil texture.
Yeah, thanks a lot. I hope the demonstration was good enough that you could learn something from that. And if anybody has any questions about anything about the presentation, I put my email on there and you can contact me directly. That'd be great. Appreciate the opportunity to talk to you all.